this is the special types of mole problems that you would have to set up. So anyway, the first thing that you're going to do is you're going to see that this is asking for, it's starting out with 2.8 grams. So you're going to start off and you're going to write 2.8 grams of dicarbon, that's C2, trisulfide, S3. And it wants you to find just the carbon atoms, just carbon, not total atoms. Okay, so the first thing that you're going to have to do is you're going to have to change to moles. So you'll go 1 mole C2S3. Then you have to do the molar mass of C2S3. So there's 2 carbons. We'll say that that's 12 grams, round a little bit, that's 24 grams. There's 3 sulfurs, and each sulfur is about 32, so that's going to equal 96. And then do the math, 10, 9, 10, 11, 12, so that's 120 grams. Okay, so that's the molar mass of CS2, or C2S3, what am I saying? All right, so after you change to moles, then we could change to the next step. We know we have to have moles down here, so we go 1 mole C2S3, and we want to go to get carbon atoms, so we're going to go 6.02 e to the 23rd, but C2S3 is not an atom, so it starts with a nonmetal, so you would have to call it a molecule. Molecule, kind of spelling it wrong. Okay, then what you would have to do is you'd have to say in 1 molecule of C2S3, so C2S3, okay, there are 2, see the 2 right there, 2 carbon atoms. You don't want to do total atoms, you just want the carbon atoms. So then you would take 2.8 times 6.02 times 2 divided by 120. And so I'm not sure what that equals, but I'm pretty sure you could figure that out. All right? Okay, the next problem. This one says, how many milligrams of just nitrogen are in 2.8 liters of dinitrogen tetroxide at standard temperature and pressure? So you would go 2.8 liters dinitrogen, tetra means 4, tetroxide. Okay, so we want to go from liters to milligrams. So there is no direct conversion. The only thing we can really change liters to get to grams is moles. So we're going to go 1 mole N2O4, and that's 22.4 liters N2O4. So that changed to moles, but we want to go to milligrams. But there is no mole to milligrams, but we could change moles to grams. And so 1 mole N2O4. So we have to add this up. So we have 2 N's, nitrogens times 14, so that's 28. And we have 4 oxygens times 16, that equals 64. Add that up, 6, 7, 8, 9. Looks like that's 92 grams. So 92 grams N2O4. That's the molar mass. But it doesn't want grams, it wants milligrams. And so there is a conversion that says in 1 gram equals 1,000 milligrams. So if we have grams here, we have to have grams here. What number goes with it? So in 1 gram, then the 1,000 milligrams would go at the top. And that's how you would set that problem up. Okay, multiply everything on the top, divide by everything on the bottom. Okay, that's it for that video.